Assalamualaikum and a very good evening everyone. We are from group 7 and we have chosen the project title of Network Address Translation for our project. First, let's talk about NAT. What does NAT stand for? NAT stands for Network Address Translation. It is a function performed by a router which translates private IP address into a public IP address. This allows within a private network to communicate with the device on the internet using a single public IP address. Now, let's move on to where does NAT commonly use. NAT is commonly used in different type of network. For example, in home network, it allows multiple devices like computers, smartphone to share one public IP. In campus network or corporate network, it helps to manage device very efficiently. Even in internet service provider or ISP for short, use NAT to conserve a limited number of public IP address while serving a large number of customers. In this project, we will learn about the three type of NAT and as well as how to use Wireshark to see the IP address inside of our NAT as our project. So let us begin.
Everyone, my name is Radin Haris bin Ghazali, and today I'll be explaining about static network address translation, which is also called static net. And what is exactly static net? That is also known as the one-to-one map. So static directly means permanent or fixed or unchanging. So it's actually a method where one private IP address is manually linked to exactly one public IP address. So this link is actually permanent and we cannot change it, and it will never change. And for example, think of it like a direct phone line from a CEO in a company. So no matter when you call, that specific number always rings that one specific person. So you cannot change the direction or the link to the phone call. So that is what is basically static net is all about. It's all about the one-to-one mapping where one private IP is manually linked to one public IP address. Now I will explain on how exactly static net works. So for the first part is outbound. Outbound is basically sending data out from our internal private server to the public internet. And so how does actually traffic leave our network? For the first step, our internal server with the private IP, as you can see on the diagram, 192.168.1.10, will send some data out, and then the router will stop the packet and checks its static net to the net table, which is also called the map. And the router will perform a swap, and it replaces the private address with the valid public IP, which is 203.0.113.5. So here we can see that there's a swapping actually happening on the static net table, and the data will travel onto the internet looking like it came from that public address. So the outside world will never see the private IP from our internet server, and they will only see the public address that has been swapped under the static net table. Just now, I've explained to you about outbound, where we are trying to send the data from our internal private server to the public internet. So now I will explain to you about inbound, which is how we are trying to receive the data from public internet. So for example, think of it like someone is trying to call you from the outside and you are trying to receive the call from the inside of your house. So the route will be from the public internet through the router, and the last destination will be our internet device. So how does it actually work? For the first step, a user on the internet will send a request to the public IP, which is 203.0.113.5, and the router, our router, will receive this packet and checks this table again, the NAT table, and when it sees that this public IP belongs to our internal server, our private internal server, the router will unswap, or it will change back the public address to our private IP address, which is 192.168.1.10, and it will forward the data to the server. So this is actually a demonstration on how static NAT is able to accept incoming connections, which is the most important feature of static NAT, static net. Now we will take a look at some of the real-world applications where static NAT is actually being implemented. So why is actually static NAT is being implemented? It is to make the public IP to remain constant so that the outsiders can find it. And this is actually very perfect for some of the examples. So for the first one is security cameras, so that you can view your home cameras from outside of your house. Second one is email servers, where external mail can find the server so that they don't get lost. And lastly is web servers, where websites hosted inside the company and the customers can always find the company website. Now we will analyze the good and the bad of static NAT. And so the good news is it is actually bidirectional. So what is actually bidirectional? It means that it allows connections to actually start from the outside, which is very essential for servers. And secondly, it also provides consistency because the IP never changes. So remember where what we said about static. So static directly means permanent, unchanging. So it is very consistent that the IP never changes. So what are the downsides of static NAT? So it is actually very expensive, to be honest. So you must actually buy a public IP for every single device. Every single device you want to map. So it does not help us conserve IP addresses. No address conservation because it does not solve the problem of running out of IP addresses. Now I will walk you through our overview of our project where we configure the static NAT. So for the first one is PC static. If we take a look at the diagram, it actually acts as the internet server or our private network. And second one is our router static will perform the translation or the gateway in the middle between the PC and laptop. So lastly is laptop static that will act as the external internet user, which is the public network or the public internet. So the flow is like exactly how the router translates the public IP request from the laptop into the private IP of the PC, which it will allow the external access to internal resources. Just like how I explained in the previous slides, our goal is actually to let the laptop to communicate with the PC so that the laptop will have a way to communicate to the internal server or our PC in this case. Now I will show you how we configure for each element that we have implemented in our project. So for the first one is PC static, which act as the internal device or the inside host. So if we take a look at the IP address, which is 192.168.10.10, this is actually a private IP, Class C private IP, and it is only valid inside the local network. And it is actually completely hidden from the outside world. So it points to a default gateway of 192.168.10.1, which is our router. It directly points to the router. So the key takeaway is actually the IP address that I have explained here is actually hidden from the outside world. So the outside world cannot directly see this IP address. Now I will show you the configuration for laptop static, which acts as the internet user or the outside host. So the IP address stated here, if you see on the diagram, is 203.0.113.10. So this is actually a public IP address, and it represents a device on the real internet. So the IP address representing a real device on the internet where the laptop can serve the web. So it cannot see our private PC directly. So it needs the router to translate it so that it can communicate with the internal server or our PC, static just now that I've explained. So the key takeaway here is this device, the laptop static, can communicate across the internet but cannot see the private IP, which is 192.168.10.10 directly. So to wrap up my presentation of static NAT, here are some of the key takeaways that we can highlight. So for the first one, it maps one private IP to one public IP. So this is the initial presentation where I've explained to you about the one-to-one mapping, which is the another name of static NAT. Secondly, it is permanent and manual, which directly means static. So static means permanent and manual. And this means that the link or the connection cannot be changed, it's unchanged. Thirdly, it is mainly used for servers. And last but not least, static NAT actually allows the outside world to initiate a connection to your internal network. This is actually the most significant feature of static NAT. It actually allow the outside world to initiate connection to your internet network or private server. Thank you so much for listening.
My name is Muhammad Adrian bin Muhammad Fuad, and I will discuss dynamic net. So previously in the presentation, we have looked at static net, which is basically a one-to-one permanent link between devices. And this section, I will talk about dynamic net. So the way to think of dynamic net is it is a first come, first serve system. And unlike static net, where a device has a reserved public IP address, in dynamic net, we have a pool. And this pool is basically like a group of available public IPs that are stored on the router. So this is the basic rule. If a device wants to go online, the device will borrow an IP from this pool. This IP address assigned is not permanent and it will not be yours forever. And it's only used temporarily for the usage of connecting. So this allows us to share a smaller number of public IPs among a large group of private computers. So let's walk through the steps of how a device actually gets onto the internet using dynamic net. So the first step is the request part. So firstly, computer A, which is currently on a private network, wants to Google something. So it sends a packet to the router. The second step is the check, where the router receives this and look at its net pool to see what is available. The third step is the assignment, where the router picks the first available public IP. In this case, it is 203.0.113.1, which is a public IP address. And the fourth step is the mapping. So this is the most important part, where the router writes a note in its net table, which effectively says that for right now, public IP 192.168.1.10, which is the IP address of the private device, which is on the private network, is equal to public IP 203.0.113.1. So once that map is created, the data can travel out to the public internet. So for slide 3, it explains on ending the session, which is basically returning the IP address. So what happens when we are done? So since this is dynamic net, we don't keep that IP address forever. So as long as we are actively surfing and actively using the internet, the router keeps that mapping alive. However, if we stop using the internet for a set amount of time, which is also known as timeout, the router clears the entry. So the public IP address that was assigned and mapped, which was 203.0.113.1, is then marked as free and goes back to the available pool. It is now ready for a different computer to use. So this recycling process is what makes dynamic net very efficient. However, as good as dynamic net can be, it also has a limit. So we call this pool exhaustion. So in this scenario, we have three public IPs in our pool, but we have four computers which are trying to get online. So computer A, B, and C take the first three spots which are available in the pool. So the pool is now empty. So when the fourth person, which is PCD, tries to connect, the router has nothing to give them, which results in the packet being dropped and the connection being blocked. So that user is basically being forced to wait until someone else disconnects to get a spot. So while dynamic net is better than static net for a large group, it still doesn't solve the problem if everyone wants to be online at the same time. So since dynamic nets can run out of addresses, you might be wondering why would we even use it? So the answer actually boils down to cost and efficiency. Dynamic net allows a large group of internal users to share a smaller, cheaper pool of public IP addresses, which works perfectly for environments where not everyone needs to be online at the exact same time. So I will discuss the three real-world examples where dynamic net is standard. So firstly, large corporate offices. Imagine a company with hundreds of employees. They might buy a pool of just 50 public IPs. So the first 50 employees to go online get a connection. And since it's quite rare for everyone to be browsing the external internet simultaneously at work, this saves the company from buying hundreds of expensive static IPs. Secondly, university computer labs. So in a classroom, students rotate in and out. So dynamic net assigns a public IP only when the student is actually using the computer. So as soon as the class ends and they log off, those IPs go back into the pool, which is ready for the next class. And finally, something like guest Wi-Fi, like in hotels or public events, where hotels have guests checking in and out every day, so it would be impossible to reserve a permanent address for every potential guest. So instead, they use dynamic pool to service just the people who are currently active in a hotel. So to summarize my section, dynamic net is about sharing, and it allows us to borrow public IPs temporarily to save money and conserve the very limited public IP addresses. So now that we understand the primary concept of dynamic net, let's look at how we actually set this up in a lab environment. So we will be using Cisco Packet Tracer. So to the left is our network topology. It's simple, but it represents a real-world edge network. So as you can see on the bottom left, which is the private side, we have PC underscore dynamic. So this represents our internal office network or our LAN, local access network. So in the middle, we have router dynamic, and this is the most important device right now. So it acts as our gateway, and this is where our pool of public IP addresses will live. So on the right side, which is the public side, we have laptop underscore dynamic. So this represents the outside world or the public internet or WAN. So the goal here is simple. The PC on the left needs to access the laptop on the right, but it has to borrow an identity from the router to do it. So this is where dynamic net comes in. So firstly, let's configure our internal user, which is trying to reach the external network. So here is our configuration screen. if you look at the IP configuration for PC underscore dynamic, we have assigned it to 192.168.20.10. So as we know, this is a private IP address and it works inside of the office in within a local access network, but it cannot exist on the public internet. So notice that the default gateway is set to 192.168.20.1. So this points directly to our router. So in a sense, it's basically our PC saying that I need to talk to the outside world. So I'm sending my traffic to the router to handle it. So now let's look at the destination device. So this is the configuration screen for laptop underscore dynamic, and it is acting as a web server or a site like Google, for example. So its current IP address is 203.0.114.10. So this is a public IP address. So this device does not know anything about our private 192.168 network, which the main device is on. So the key takeaway for this setup is when the PC sends a packet to this laptop, the laptop will receive it. But when it replies, it won't be replying to the private PC directly. It will be replying to the public IP that the router assigned from the pool. It effectively thinks that it's talking to the router and not the PC inside. So before we move on into the next solution, let's quickly recap the four things that we need to remember about dynamic net. So firstly, the concept is it maps internal private IP addresses to a shared pool of public IP addresses which are stored on the router. The rule is it operates on a first come, first served basis. So if there are any available IP addresses available, you will get it. If there isn't, the device that needs to connect needs to wait for available IP addresses to be free. So thirdly, the benefit is dynamic net saves money. So an organization does not need to buy a public IP address for every single device in a building. It just needs to buy just enough for the people to be active at one time. So the risk of dynamic net is the biggest limitation is pool exhaustion. And it works in the sense that if that pool of public IP addresses runs empty, new connections will fail until someone else logs off. So dynamic net solves the cost problem, but it does not essentially solve the scale problem if everyone needs to be aligned at once. So to solve that issue, Afiq will present and will walk us through PAT, which is port address translation, which is the version of net that we all use in our homes every day. So thank you.
Now, let's move on to the third and final type of NAT. Now, we have PAT, or referring to port address translation. Now, what is a port address translation, or PAT? PAT is a type of network address translation that allows multiple devices inside a private network to share a single public address. It is also known as NAT overload because there are many internal devices that are mapped to one external address. PAT works by assigning different port numbers to each device traffic so that the router can identify which data belong to which device and forward it correctly, even when many connections are happening at the same time. Now let's move on to why PAT, or port address translation, is needed. PAT is important because IPv4 addresses are very limited. While today's network has so many devices that can be connected at once, but by allowing multiple private addresses to use one public IP address, PAT helps to conserve this public address efficiently. Because of this, PAT is commonly used inside of home network, campus network, and small office where many users access have internet access, but only a small number of public IP addresses are available. Now, let's move on to the advantages of port address translation, or PAT. The first advantage of PAT is that it allows many devices to connect to the internet at the same time. Even though there may be a dozen or even hundreds of devices in a network, all of them can share a single public IP address. This makes PAT very practical in environments like homes, campus, and even offices. The second advantage of PAT is it adds a basic security by hiding private IP addresses. Internal devices are used IP addresses that are not visible to the outside world. This means that external user cannot directly access device inside the network, which helps protect internal system from unauthorized access. The third advantage of PAT is that it is simple and also cost effective. Network administrators do not need to purchase many public IP addresses or configure complex routing rules. PAT can be easily set up on routers and work automatically once configured, reducing both cost and also management effort. And also lastly, the final advantages is that PAT helps save public IP address. Because of the IPv4 address are limited, PAT allows efficient use of available addresses by enabling many private devices to share one single public IP address. This helps extend the lifespan of IPv4 and supports the growing network demands. Now, let's move on to the disadvantages of port address translation, or we know as PAT. The first disadvantage is it is a complex in troubleshooting. Because of many devices share a single public IP address, it can be difficult for network the administrator to identify which internal device that is causing the network problem. This takes monitoring and debugging network issues more challenging. The second disadvantage is that it is limited inbound access. PAT works very well in outgoing connection, but it is not suitable for incoming connection by default. Services such as web server or gaming servers inside the network require additional configuration like port forwarding, which can be more complicated. The third disadvantage is that it is a single point of failure. Since all devices rely on one router and one public IP address, if the router fails, all connected devices will lose internet access at the same time. And lastly, the final disadvantage is protocol limitation. Some network protocol would not work well with PAT because they embedded IP address information within the data payload. These protocols may require special handling or may fail to function properly when PAT is used. Next, I will explain step-by-step process on how we implement port address translation in our network, also known as PAT. Firstly, we set up the network topology. The network consists of a single router, a switch, two private PC, and also one public server. The private PC are connected to the switch, which is then connected to the router, and the router also is connected to the public server, in which case the public server here is a laptop. Second, we assign IP address to all devices. The private PC will assign IP address in the range of 192.168.1.x. The inside of the interface of the router was assigned of the IP address 192.168.1.1, and also the outside interface of the router was assigned with the public IP address of 303.203.0.113.1. Finally, the public server will assign the IP address of 203.0.113.10. Thirdly, we configure the router interface for NAT. The interface is connected to the private network was configured as the inside of the interface is used to command the IP NAT inside. The interface connected to the public network was configured as the outside interface using the command IP NAT outside. Next, we define the private network using an access control list. We created an access list number 1 to permit the private network range of 192.168.1.0 with a mask of 0.0.0.255. This tells the router which internet address are allowed to be translated. After that, we enable the PAT or port addressing translation on the router. We use the command IP NAT inside source list 1 interface G0/1 overload. That this code allows all private devices in the access list 1 to share router public IP address using different port numbers. And lastly, we tested and verified the configuration. We tested the connectivity by pinging the public server from private PC to confirm that PAT is working. We use the command that is show IP NAT translation to view all the active NAT entries on the router. Finally, in conclusion, port address translation, or as known as PAT, is a very efficient networking solution that allows multiple private devices to share a single IP address. By using different port numbers, PAT enables many devices to access the internet simultaneously without requiring multiple public IP addresses. PAT is also especially important because IPv4 addresses are very limited, yet the number of the connected devices continue to grow. It provided a cost-effective and practical way to conserve public IP address while still supporting network connectivity. In addition though, PAT offers basic security by hiding private IP addresses from external network. And overall, PAT is widely used in home, campus, and small office network because it is very simple to implement. It is also reliable and effective in managing internet access for multiple users.
So in this demo, I will demonstrate how static network address translation works by using Cisco Packet Tracer and also Wireshark. So the objective is to allow a private host to access a public web server by translating its private IP address and into a public IP address. So in this topology, we have four main devices, which is a private PC, a NAT router, a public router, and also a public server. So the PC is in a private network, while the server is in a public network. So the private PC has IP address of 192.168.10.11, while the public web server has an IP address of 138.76.29.8. So okay, as you can see, the PC is physically connected to a NAT router on the inside interface, and the NAT router is connected to another router that represents public network, and then the last one, the public router, is connected to a public server. Then for demonstration, I will ping from the private PC to the public server. Ping 138.138.76.29.8. Okay, wait, we try again. We ping again. Okay. So we successfully ping from private PC to the public server. So if we see in the router one, which is NAT router, we go to the CLI, and then we can see the network translation confirmation static. We can see the NAT table actually. So as you can see below, we already translated from the previous one, which is start from 198, right? And then we change to so NAT already translate the IP address from private to public, which is 10.0.0.255. 255 or 254? Okay. To further verify the translation, the packet capture is exported and we open in Wireshark. Okay, so as you can see, this is the captured packet. So wait, okay, and then we use the filter, HTTP filter. Click. HTTP filter. This one is in the Wireshark. So as you can see, this is before we use NAT, which is network address translation. As you can see, we can see the original IP address, and then we do the same. You see, this is after NAT translation, so it translates from private IP address to public IP address, which is now you can see 10.0.0.254. That is the IP address we get after the translation. So in conclusion, this demo proved that static NAT, which is network address translation, successfully allows a private host to communicate with a public server. The translation is permanent, readable, and verified by using both Cisco, Packet Tracer, and also Wireshark. So as a conclusion, this demo shows how static network address translation works, and it enables from private to public communication by using a real application traffic.
Now let's compare all three types of NAT. We have the static NAT, we have the dynamic NAT, and we also have PAT or port address translation NAT. Now, for static NAT, it provides one-to-one mapping between private and also public IP addresses. This allows devices to be accessed from outside of the network, but it requires a high number of public IP address and also has a very low scalability. Whereas dynamic NAT maps many private addresses to a pool of public IP addresses. This reduces the number of public addresses that need to be compared to static NAT, but it also does not support outside access and only have a medium scalability. And lastly, we have a PAT, or as known as port address translation. Also, many private devices share a single public IP using different port numbers. It is highly scalable and also uses public IP very efficiently, although outside access is not allowed. In short, PAT is the best choice for network with many devices and a limited public IP address, while static NAT is better if outside access is needed, while as dynamic NAT is the only middle option.
So, in conclusion, network address translation enables communication between a private and a public network by translating its IP addresses at the router. So, because private IP addresses are not routable on the internet, NAT or network address translation allows internal devices to access external networks. So, in the demonstration before, static NAT provides a one-to-one mapping between a private IP address and a public IP address. So, the source address is translated when traffic leaves the private network, and the response is translated back automatically. So this translation process works independently of application protocols such as HTTP traffic, as I demonstrated before. So in addition, NAT provides a basic safety precaution by hiding its internal IP address from external network. And then NAT also helps in conserving public IP addresses by allowing organizations to use private addressing internally.